you for listening to today's episode of JATCast, the official podcast of the Journal of Athletic Training. I'm your host, Luke Donovan. This month we'll discuss 2 articles over 2 short episodes from the recent issue of the Journal of Athletic Training. The 2 articles will cover the primary findings of a 2-part series of studies, where the first episode will discuss brain activity differences in individuals at high and low risk of sustaining an ACL injury. Well, the second episode will highlight the findings of the second study, which aimed to determine the relationship between brain activity and biomechanical changes following neuromuscular training with biofeedback. As a reminder, the article discussed today can be found on the JAT website, natajournals.org. And please remember that all content from JAT is open access to all readers, thanks to the funding from the National Athletic Trainers Association. The title of the first article is Preliminary Report on the Train the Brain Project, Sensorimotor Neural Correlates of Anterior Cruciate Ligament Injury Risk Biomechanics, Part 1. Authored by Dr. Dustin Grooms and colleagues from Ohio University, Emory Sports Performance and Research Center, Emory Sports Medicine Center, Emory University School of Medicine, Cincinnati Children's Hospital Medical Center, the University of Michigan, and the McKaylee Center for Sports Injury Prevention. Let's survey the scene. It is well established that there are numerous health benefits to engaging in physical activity. Despite these benefits, participating in physical activity does increase an individual's risk of sustaining musculoskeletal injuries, some of which, such as injury to the ACL, may decrease one's ability to remain physically active, thus increasing the risk of developing chronic diseases over their lifespan. Specific to ACL injury, and among female adolescent athletes, neuromuscular control has been shown to be a contributing factor to sustaining these injuries. Knee abduction landing mechanics during a drop vertical jump has been shown to be a reliable screening tool to identify young female athletes who are at a greater risk of sustaining an ACL injury. Although reliable, the screening tool in isolation does not necessarily provide insight to the breakdown in the sensorimotor system. To capture the neural activity aspect of injury risk, investigators measured the resting state electrocortical activity differences between female athletes categorized as high or low risk of ACL injury, based on their peak external knee abduction moment during a landing task. These preliminary reports found that individuals in the high-risk category demonstrated a more predictable neural profile than individuals in the low-risk category. As such, considering the predictable neural activity, it appears that individuals with a high risk of biomechanic profile may have a decreased ability to adapt their movement when exposed to unanticipated perturbation. Although the findings of these works are informative, the neural activity was quantified during rest. Capturing neural activity during movement may further identify central nervous system processes for neuromuscular control during tasks predictable of ACL injury. Therefore, the purpose of this investigation was to evaluate neural correlates of isolated knee joint and multi-joint control of the lower extremity relative to their injury risk category evaluated during a drop vertical jump. 31 female high school soccer players between the ages of 13 and 19 who met the inclusion criteria completed a standardized drop vertical jump to determine their injury risk group. During the drop vertical jump, participants also had their peak external knee abduction moment calculated using standard 3-dimensional biomechanical assessment procedures. Based on their peak external knee abduction moment, of the 31 individuals, 9 were placed in the high risk and 11 into the low risk groups. The remaining 11 individuals who did not meet the thresholds of being considered either high or low were excluded from the study. Following the biomechanical assessment, participants had their cortical activity recorded by way of functional MRI while simultaneously completing 2 different movement strategies. The first task was an isolated knee extension flexion task, where the participant moved their lower limb between terminal knee extension and 45 degrees of flexion at standardized pace set by a metronome. Following the isolated knee movement tasks and at the same movement pace, the participants completed a leg press task to simulate movement from multiple lower extremity joints. After accounting for head movement during the neuroimaging, the final analysis was performed on 5 pairs of individuals. Here are the results. Participants with high injury risk biomechanics demonstrated less neural activity in the precuneus cluster for the isolated knee movement task than the low-risk group. Furthermore, during the multi-joint leg press, individuals with high injury risk biomechanics displayed greater brain activity in the frontal cortex and the posterior cingulate gyrus clusters. The findings of this study suggest that high injury risk biomechanics is related to differential brain activation strategies. Let's talk a little bit more about these findings. The isolated knee movement task was completed in the open chain where the foot never touched the table. This task was designed to engage proprioceptive prediction, feedback, and spatial awareness during each repetition as the participant needed to move through a specific range of motion with no visual or tactile influence. The precuneus region of the brain contributes to regulating proprioceptive feedback to refine limb spatial location. Given the region's role to integrate sensorimotor information, decreased activity in this respective region may have reduced the participant's ability to maintain knee alignment during the landing task, in turn contributing to their high peak knee abduction moment during that task. Differing than the results during the isolated knee movement task, which showed the high-risk group as having less sensorimotor activity, during the multi-joint leg press, individuals with high injury risk had greater cognitive motor activity, represented by increased activity within the frontal cortex and posterior cingulate gyrus regions. In other words, there appears to be a greater cognitive demand during the multi-joint movement for individuals with high injury risk. Speculating the findings into the context of sport, increased cognitive demands may prove harmful when paired with the external distractors in unpredictable environments associated with most sports. Limited capacity for complex motor coordination may, in turn, lead to a breakdown in neuromuscular control, which in this case was depicted by the high peak external knee abduction moments during the landing task among these individuals. In summary, the study found that young female soccer athletes who are categorized as high injury risk based on their biomechanic profile during a landing task display different sensory and cognitive neuroactivation strategies when compared to peers with a low injury risk. The findings may have implications for both ACL injury risk reduction training and post-ACL injury rehabilitation programs. Well, that's it for today's JATCast. Please remember to rate and subscribe to the podcast, which is available on iTunes, Google Play, Spotify, YouTube, and Stitcher. You can find out more information about upcoming podcasts and other JAT events on our Twitter, Facebook, and Instagram accounts at JAT_NATA. Thank you for listening and keep a lookout for our next JATcast episode.